Hey everybody, this is Dr. Pingle recording a quick lab report here on the 27th of December. This is more just a note than anything else, but this is color set, some perceptually uniform color maps that I ran across as I was looking for something else. I got an email from NGA, the National Geospatial Intelligence Agency. They were advertising, I don't know, is it Terraline or Tierline? But collaboration with them on various projects, something that I would like to do more of in the future. Um, this is an HDMI for FPV on an ArduPilot drone. I'm likely to get two of these when I get back from my trip. We'll put one on the rover and one on the little aerial drone, Busy Bee. Nice FPV. And then that way the camera is effectively independent um, of the FPV, which is, I think, simpler. This is some YOLO V5 performance testing. So previously, I outlined how to get going on this really quick and easy to get started downloading the repo. I was curious about how fast different different runs would be, and so I ran some tests on my 3060 at home with a 10-core i7. It took about 2.4 times longer than the Whopper at school with the 4090, which is, I think, the definitive piece of hardware on that machine. Processor is also faster, but I think the 4090 is what is speeding things up quite so much. That's a pretty big improvement, enough to worry about? Probably not. I'm not sure what the memory is on the two machines that we have at school. Probably on the order of 8 gigabytes. So that's probably a bigger concern. And I didn't even try, increasing the batch size or anything. So yeah, this is quite fast on the 4090. Spent a lot of time trying to prep the ground for the work that Gianna and Lily are going to be doing. So I really wanted to spend some time on 3D building printing. I did try the Geomagic Wrap program. I got a free trial. Basically just stalled out on anything that I gave it, so no luck there. On the alumni building, I extracted a little section out and then basically ran through the exact same steps that I've got online that we developed many years ago. And it worked just fine. It did exactly what it is supposed to do. So the ground wrapped around down below. In fact, I don't even know if I made a floor on this. I guess I probably did. But yeah, this worked exactly as before, so I'm not really sure why it's not working on the whole brain. There's a lot of different options here for working in Autodesk Fusion, working with meshes. So this is just ingesting the mesh and then trying some different things out here. But it is really nice that it's so easy to get these in place. If all you want to do is close holes, that's easy to do. You get this warning. You can click close holes and then just hit OK here. This is a tiny little fraction of the model, so it doesn't take long to run this. And then as you flip it under, you can see that it's put those out. There's a couple weird spots there. I don't know what that is, if that's some kind of a courtyard or atrium or what, kind of a strange structure on the building. And that kind of goes to the floor, so that would have to be probably manually cleaned up in some way, but not a problem with the meshing. This is the original STL. When I bring this into Cura, it actually looks just fine. This is probably on a 1 to 1000 scale or something. Yeah, I don't know quite what to make of this. I didn't try printing it out, so I probably should do that. But you know, the goal isn't to just print out the alumni center; it's to print everything out. Although, you know, really easy to just do this. Yeah. If you take the whole thing and take the same cloud compare Poisson surface reconstruction output that we've done, and try to run some of those same hole repairing tools in Fusion, you get pretty weird results. This is the fill holes, and the stitch and remove actually gave the same result. I don't even quite know what it's doing here. Clearly, a bunch of the ground is being sort of peeled off. Yeah, strange. The wrap function was a little bit better, but still not really what we're after. Rebuild was totally bizarre. Blocky was kind of neat. You know, sort of like the voxel-based system doesn't really do anything like what we want it to do, but it is a neat effect. Carl had recommended trying out Claude, Anthropic's AI, and it was, you know, worth a try. You know, try to define some specifications for what this would do and let it do its thing. You know, I didn't try all that hard to optimize here, so I'm not saying it can't be done. It probably can be done, but it certainly wasn't as easy as like do what I wanted it to do, which was to just find the outer edge of a mesh and then extend that downward and um, then make it flat. So yeah, a little odd. This is the output of that. You know, it did something. It processed the data. It spit it out. It wasn't anything like what I wanted. Yeah, these slides are mixed. I'm gonna have to scoot these around probably. Um, but yeah, the 3D modeling. Yeah, these are all over the place. 3D modeling. Yeah, didn't. I tried. I guess what I'm trying to get at here is using the ground classification that came off of the DJI to drive a bottom on this that wouldn't be just sort of like a flat bottom, but would be tuned to the contours a little bit of the space, because that was, you know, my hypothesis why it didn't wrap around, but it did not work. So where to next? I think asking Paul at ETS if the slicers can do this job. I guess I don't know, you know, if for instance, if I simplify the um, if I simplify the mesh, maybe Kira can read it and then Kira can just print it. So that's totally possible. Um, but I don't know. And then I haven't played at all with like the X1 Carbon's bamboo slicer. So I don't know if there's anything in there that'll do the work. And then lately I've been exploring reality capture again for this kind of work, and I'll talk more about that in a little bit. All right, so if I've talked about this, I apologize, but Sharman and Alana and I were talking about running a comparison of the empirical thermal data that I gathered over the summer with the simulation that Sharman had run in Solwig. Essentially, the gist was to take both models, the empirical model, which is not calibrated, it's got temperature values, but I didn't have any thermal ground control points, so I don't really know how well those reflect. I think they're sort of relatively correct, but it might be that the temperatures are off by plus 20 degrees, or it might be that they're stretched. But it's a linear transformation between this and real temperatures. And so what I did was use the Solwig model, sampled I think 10,000 points on the surface, drew drew the values from both of those surfaces, ran a regression against them, and then transformed the um, empirical model to the Solwig model's sort of measurement space. and then use a raster calculator essentially to do that. And so what you get is this difference pattern between Solvig um, and the empirical measurement. And what you find is that in some places the Solvig model is too hot. So in a lot of places with land covers that you would expect with increased temperatures, those temperatures are hotter than they should be. Similarly, some of the vegetated areas are cooler than they should be. So basically the Solvig model is more extreme than you would actually expect it to be on the ground. I used some of that analysis in the proposal that I submitted to the provost, hoping to get a little bit of funding for Alana to take some more empirical measurements starting in the summer. The correlation between the measurement and the simulation is about R equals 0.56. So it's not great. You would expect that to be, you wouldn't really expect it to be 1-to-1, although that would be nice. I don't know. I feel like 85 would be a good number here, maybe 90. But anyway, it is what it is. But I think that's room for improvement on these models for sure. One of the things that I don't have is because those temperatures were calibrated, or because those empirical measurements weren't calibrated, we don't really know whether the model typically runs hot or cold. In fact, you'd have to sort of get a sense of what an average temperature is for that particular day to be able to do that anyway. So there's always going to be some recentering, I think. But yeah, overall performance, I would say, is mediocre. So, oh, and this is in the wrong spot here. So this is notes to Alana and Sherman. Oh, all of this is in the wrong spot. Okay, strange. Yeah, this is the original paper for, or actually this isn't the original paper, but this is a recent paper on Solvig. They're using some GPU methods to calculate sky view factor, which I'm pretty sure the way that I'm doing it in NeilPy is at least as fast as this, probably faster. You don't need to iterate. You can, there's better ways to do this. Yeah, the other thing is I'm not even sure why sky view factor is really the thing to do. You would think that, something a little bit more like a hillshade where you're, hillshades with shadows would be a better way to do this. It's not obvious to me why SVF is the right answer here. So I don't know. We haven't applied into this. Hopefully Alana will get into the details of Solvig a little bit. I think Sharman's goal is to use it as a tool as is, which is good. But I'm hoping that the empirical measurements that Alana gathers are going to feed into a more robust model. And then this is the grant we submitted, that I submitted for the provost. The deadline of that was December 6th. I don't know if I've recorded, it seems like I have recorded something since then, but maybe because I didn't talk about the thermal stuff, it didn't get in there. A little bit of the thing. It was pretty short. I don't even remember how long it was now, but 3 pages or something, ridiculously short. Be a good example for a proposal for the grad students, I think, to show how tight a proposal can get. Okay, I spent some time on Peter's work. What I wanted to do is sort of see how well the LiDAR was going to capture deer trails in CIW. Okay, so one of the neat things that I discovered while I was prepping around, I accidentally set LasGrid, which I usually do to create DSMs and DTMs and whatnot. I had set for an output file of an LAZ, and I was like, oh, that's weird. Let's just see what happens. It does, in fact, output an LAZ, so that was neat. And what it does is, in this case, it keeps the maximum value that it got. So that's why things look like it didn't hit the ground, sort of the exact shape of the tree. Yeah, pretty cool. this is a sense of the steps that I used to make these sub-canopy height model measurements. The idea was create a canopy height model, but instead of rendering from like above the canopy, render it from a position sort of in the canopy, like between the canopy and the ground, to try to image the sub canopy. I've never seen like a visualization that should be, essentially a visualization of the sub canopy, of the underbrush, or whatever it is that you're going to want to call it. So the steps here, create a median ground surface at 1 meter resolution. I think you could do even coarser than 1. Probably, probably 5 would be fine. 2 would certainly be fine. But anyway, 1 is what I picked. And then generate CHM point cloud, where the Z is now the height above ground. It's the sort of standard LazTools approach, and there's the cube for that. And then create the high-res gridded CHM at various heights and resolutions. The idea here is you're going to load that CHM, and then you're going to render it back out again as a DSM, but you're using this keep Z with a range here, -5 to 2, which says, render this at only these heights. And so it's a kind of a neat way to render that sub canopy and visualize, I would think, the effect of deer populations on the sub canopy, to the extent that you can. But anyway, this all went fine, and the location of that is given there at the bottom. And then once you there's a bunch of these options effectively, and then the question is sort of what of these options yield the best visual result as an indicator of what's the best analytical result. And so this is I think a mild preference for vertical exaggeration of 3. With a VE of 1, the whole thing renders pretty white. So it darkens as it goes, but I think that darkening helps bring out some of the major tracks and trails. Now, a lot of these tracks and trails are pretty well documented, but I think it's findable. You can pretty clearly see the trails kind of running through the area. Not crystal clear, but pretty clear. I would say that I liked the 10 meter a little bit better than the 5 meter. So there's the 10. I think it's just a slightly clearer result. Played around with a lot of different canopy heights to try this on, even including 5 meter. That's this one. 4 meter, 3 meter, 2 meter, 1 meter is pretty great. And then 0.5 meter, I think, cleans things up a little bit. I don't think there's much of a substantive difference between 1 and 0.5. So I think all of those work pretty well. Leaf on at 10 centimeters leaves a lot of gaps in the data. So that's not great. I think that the hope is that we could use leaf on to do this work, but not at 10 centimeter, which it has a lot of bearing on the stuff that I'm doing on the Solomons and whatnot. What are we going to be able to do with LiDAR scans, and that it's not super dense vegetation, but it's pretty dense. So anyway, I would say this is mildly discouraging, but it is what it is. 20 centimeters leaves very few holes, and I'm trying to clearly accentuate the holes in this yellow, but yeah, leaf on, not so great. Always playing around with different visualization schemes. I generally sort of default these days to either a multi-directional hillshade with a little bit of vertical exaggeration, or just slope mapping and then pinning the white and black to 0 and 45 degrees respectively. Although you can play with that when it's at a really fine scale. But standard hillshade doesn't really show much here. I tried a bunch of other stuff: layer blending, roughness, sky view, profile, curvature, intensity. None of that stuff really did anything that I wasn't already getting with slope. It might be interesting to run something like the vector roughness measure or something. Maybe I'll make a note about that. Yeah, this was the sky view. You know, are the trails visible? Definitely that kind of one that runs, twists and turns a little bit, but runs left to right. Yeah, it's kind of visible, but more so than the slope. I don't really think so. Tried a couple of different, vertical exaggerations and whatnot. I ran into this paper, which is the normalized return density as a metric for looking at the density of the understory. This is a fairly clever idea, I guess, and the idea is that the ordinary density is something like you're going to take the number of points in a given area and divide that by the total number of points in that like height band. So 0 to 2 meters or whatever it is. And oftentimes they're going to say, the ground is anything under 0.25 because you're never going to get to the ground. So it's always kind of fuzzy. So understory is 0.25 to 2 meters. So the typical way to do that is to divide the 0.2, however many points you have in that 0.25 to 2, divide that by the total number of points in that unit of area total. But as the authors point out, and I know at least Phil Dennison a little bit in passing, take the same number of points in that given area from 0.25 to 2, but then instead of dividing that by everything, so that the I to J is still right. You would divide hang on. Now I've got this backwards. Sort of had this in my head and now it's gone. What's confusing me is that the divisor here is 0 to J. And below. Yeah, okay. So you're gonna compare it to the total number of points in that column down to 0. Yeah, I guess that's right because that's going to be comparing it to the idea is that the overstory preferentially absorbs the LiDAR signal effectively. So you're gonna if you've got an area of grassland, but then you put trees above it, just sort of poof, trees come in. Well, a lot of the density is going to come off of those trees first, but it's going to be the exact same vegetation density. So that by dividing what's below it, you end up, discounting that effect of the canopy eating that signal and only counting what's below it. I guess I'd have to think about that a little bit. Yeah, I guess I'd have to think about that a little bit. Can I play this? I can. Okay, so this is a little slice of what it looks like. This is leaf. Boy, it sure looks like leaf on, even though I guess I thought, I don't know. I guess this is leaf on. But yeah, a lot of the points don't really get down all the way to the surface. There's a lot of missing data in here. All right, let's talk about Ranu Raraku. This is the last little bit here. Sort of eternally trying to, see what the best way to handle this relatively large data set. And I would really consider it relatively large and not very large. It's like 12,000 some images for each of two sets, one at 30 and one at 60 meters. What's the best way to process that? If you just dump all of those images into Pix4D, even just at one of those altitudes, you don't get a great result. So I took all of the 30 meter stuff, pre-calibrated a section of it, hoping to avoid a big, long calibration phase, which, I don't know, maybe that ended up costing me time, but trying to take the camera model out of the equation, set that to not try to calibrate the internals. I didn't even check geometric validation. It still probably took 2 weeks to do, a little less than 13,000 images. So then it was kind of back to the drawing board there. I discovered that reality capture is free, so I'm certainly pursuing that. I tried to run all of the, I think 30, in fact, I don't think I was running all of them, but tried to run a subset of the 30 meter data set, and something ended up crashing Whopper, which kind of a neat thing, found out that I could reboot it from one of the computers on campus, so that was pretty great. So then what I did was take the 60 meter data set and split it into 2,000 image chunks. There were 6 of those. Each one took only between like 3 and 4.5 hours to run, which was great. And that's with the full settings. So geometric validation, rematching, full image size, the whole 9 yards. And this has to be the right way to do it. You could run all 6 concurrently. I don't think you'd blow up the memory on the machine. I have to think that would be the fastest way to get to the end. Maybe it's going to take more than 4.5 hours, but more than 9. I don't know. But then merge them all together. So jumping around just a little bit here, the reality capture stuff was really easy to get at. Capturingreality.com/download now. You have to install the Epic Game Launcher and then install it from there. It's free for educational use, so it validated against my Binghamton address. And it seems like in this typical, you can only run one instance of this with your email at one time. So when the Whopper was sad, it had been running reality capture, so I couldn't get it started on the grad student machine. Things like that. I actually couldn't get it installed on my home machine, but I'm going to be rebuilding a new machine for myself. The back half of the break, it is time. I'm starting. What I realized was my Windows 11 machine hasn't been updating to keep track of the most current version. So I'm sort of like, I'm on Windows 11, but I'm not on the most current version of Windows 11. So I gotta get that fixed. When you run these 2,000 image models and load them, it merges the project initially quite quickly, but that doesn't do anything to adjust the positions. I think it does maybe adjust I don't know, it uses the same camera model for everything, so I'm not quite sure how that works, but yeah, you get these weird patterns, straight lines and seams in the model. One of the choices that you get when you're merging projects are these 2 choices. The first one, it's kind of grayed out here, but it says duplicate camera parameters. I looked at the Pix4D documentation here, and it was like, sure, it improves the results. Never uncheck it unless it's a single data capture on a single day with similar weather, which is I think the case here. I guess I don't know that for sure. In fact, that's maybe a good question for Carl. But the second question is one that I really just have been at for a long time, but some projects have objects with the same name and type. Do you want to treat them as identical? I don't know what that is. None of these have MTPs or GCPs. That's usually what I would want to kind of keep the same name. And so if there are other projects that have what would those objects be? I just can't really figure it out because the camera stuff was in the previous one. I don't know. So anyway, I said no to both of these in the current run, and I'm running the reoptimization now. It's been running for 10 hours and it's still not done. That's fine. It's a big project. No big concerns there. I guess what I hope to see after that's done is whether these obvious seams go away. I don't know, the overall accuracy of the model I won't be able to assess without GCPs, but eyeballing it is clearly stuff that's not right, that you can tell right away. So yeah, hopefully this all comes together. And then this was kind of a neat hack. This is the final bit that I'll mention here. What's the right way to do this? A lot of times they're like, well, run it as a single project if you can, which, is what we're doing. It's not all that many images, but it still takes forever. It's just not optimized to fully utilize the CPU and GPU. But anyway, the one of the neat things is you can define the processing area. So you can always do this in Pixel4D Mapper, right? You can go and draw a polygon that's whatever it is that you care about. But the neat thing here, I think, is this idea of rendering out the point clouds and potentially even the meshes using these processing areas. So it's a very clever idea, and I'll have to give this a try, because usually the step 2 takes a super long time, and so if you could maybe divide things out, maybe it wouldn't take quite so long. I will be trying to output the meshes and stuff once I get one of these projects to come together.